Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Biomolecules. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them. Also, in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section. Then we shall give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that thyroxine produced in the thyroid gland is an iodinated derivative of, so that will be tyrosine. So thyroxine, it is an so it is present in the thyroid gland. It is a hormone which is produced by the thyroid gland, and it is actually an iodinated derivative of tyrosine. Iodinated derivative of tyrosine. So option A is the correct answer. Then here it is told sucrose is dextrorotatory, but after hydrolysis the mixture shows levo rotation. This is b- because of. So this is because of the levo rotation of fructose is more than dextro rotation of glucose. It means that when sucrose when sucrose undergoes hydrolysis, then a mixture of the D and L forms are formed. Here we have a mixture of products is formed. Now, as you know, sucrose is always dextrorotatory, or it is plus form, and when the on hydrolysis the sucrose forms some mixture of products, and this uh, uh, m- 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 mixture, it contains the L fructose and D glucose. Now the amount of L fructose is more than the amount of D glucose which is formed. So so hence the mixture as a whole, it acts as l- l- levorotatory. Since L is more than D, so the net mixture, it shows levo rotation only. So hence option B is the correct answer. That the levo rotation of fructose is more than the dextro rotation of glucose, which is formed by the hydrolysis of sucrose. Then here it is told that the correct order of match in between column X and column Y is. Now vitamin A, now the deficiency of vitamin A causes night blindness. It causes night blindness. So 1 will match with 3, and the deficiency of vitamin D, causes osteomalacia. Osteomalacia means there will be weak bones. So it means that 2 will match with 4. And then the deficiency of the deficiency of vitamin E causes uh, muscular weakness. It causes muscular weakness. It means that 3 will match with 1. Then it is told that deficiency of vitamin K, the deficiency of vitamin K causes increased blood clotting time, increased increased blood clotting time. Since the vitamin K, it helps in the blood clotting. So it means that the 4 will match with 2. So it means 1 matches with 3, 2 matches with 4, 3 with 1, and 4 with 2. So option B is the correct answer. Then here it is told uh, receptors are proteins and crucial to body communication process. These receptors are embedded in. Now, receptors are proteins and crucial to body communication process. These receptors are embedded in the cell membrane. The rule is that the receptors which are helpful in the body communication, which are helpful in body communication process, are embedded in the cell m- m- membrane and cell membrane. So option C is the correct answer. Then it is told which of the following gases converts hemoglobin into hemoglobin. Now hemoglobin in the blood, it will be oxidized to carboxyhemoglobin in the when there is absence of oxygen, or when there is limited supply of oxygen, and the gas is carbon mo- m- monoxide. So hemoglobin reacts with carbon monoxide to produce carboxyhemoglobin. So option C is the correct answer. Then it is told pick out the one which does not belong to the fa- family, which does not belong to the family. Now Talin, talin, then lipase, then pepsin, all these are the enzymes. All these are enzymes. But cellulose, it is a polysaccharide. It is not an enzyme. It is a polysaccharide, which is not an enzyme. So hence the remaining three are enzymes, but only cellulose is not an enzyme. So it does not belong to the family of enzymes. So option 4 is the correct answer. Then here it is told pick out the unsaturated fatty acid from the following. Pick out the unsaturated fatty acids from the following. Now, oleic acid, it has got one double bond. It has got one double bond, and its molecular formula is C7H17H29 COOH. So if it is a saturated fatty acids, then if it is a saturated fatty acid, then it should be of the form CnH2n plus 1 COH. So it means that it should have been C17H um, 35 or no, it should be of the form C17H2n minus 3 COH if it is a saturated fatty acid. So it means that if it has 17 carbon atoms, then it should be C17H31 COH, which is called as the palmitic acid. Palmitic acid. So palmitic acid, it has no double bonds. No double bonds. It means that it is a saturated fatty acid. And since oleic acid, it has got one double bond, so it is an unsaturated fatty acid. Unsaturated fatty acid. So, and in case of stearic acid and lauric acid are also saturated fatty acid. Stearic and lauric acids are also saturated fatty acids since they have no unsaturation, since all carbon-carbon bonds are single bonds only. So they are also saturated fatty acids. So the only unsaturated fatty acid is the oleic acid. So option 1 is the correct answer. Then here it is said that a nucleoside on hydrolysis gives. So a nucleoside on hydrolysis, it will give an aldo pentose. It will give an aldo pentose which contains pentose sugar, which contains a pentose sugar, and it will give a heterocyclic base. It will give a heterocyclic base, which which can be either a pyrene base or a pyrimidine base. We can also call it as a heterocyclic nitrogenous base. Nitrogenous base it will give, which can be either a pyrene base or it can be a pyrimidine base also. So it will give an aldo pentose and a heterocyclic base. So option 1 is the correct answer. Then it is said which of the following biomolecules contain a non-transition metal ion? Which of the following biomolecules contain a non-transition m- m- metal ion? Now, chlorophyll, it contains magnesium. Since chlorophyll, it, it is also it is also called, it is a magnesium porphyrin complex. It is a magnesium porphyrin complex which helps in the green or which is present in the green pigment of plants. which is present in the green pigment in plants. And in case of vitamin B12, it contains cobalt. It contains cobalt, which is obviously a transition metal ion. It is a transition metal ion. And magnesium Mg, it is not a transition metal ion, so it is a non-transition metal ion. And hemoglobin, hemoglobin, as we know, it contains iron. It contains iron Fe, which is obviously a transition metal only. And insulin, insulin also it contains zinc. Insulin, it contains zinc, which is also a transition metal ion. And insulin contains sulfur also, which is a non metal. So chlorophyll is the only biomolecule which contains a non-transition metal ion. So option 2 is the correct answer. Then here it is told sucrose molecule is made up of. Sucrose molecule, it is made up of an alpha D glucopyranose. I- In sucrose, as we know, an alpha D glucopyranose unit, an alpha D glucopyranose unit is linked with uh, a beta D fructofuranose unit. Beta D fructofuranose unit, and which is linked by a C1 C2 alpha beta glycosidic linkage. C1 C2 alpha beta glycosidic linkage. So it means a glucopyranose is linked with a fructofuranose. So option 2 is the correct answer. Then water insoluble component of starches. Water insoluble component of starch is amylopectin. Amylopectin is the water insoluble component of starch, but amylose and cellulose, they are water soluble component. No, cellulose is not a component, but a- amylose is a water soluble component of starch. Water soluble component of starch. So only amylopectin is the o- water insoluble component of starch. So option 1 is the correct answer. Then here it is said that an example of for a saturated fatty acid present in nature is an example for a saturated fatty acid present in nature is. Now in oleic acid, its molecular formula is C17H29COH. So now, so it has got one double bond. It has got one double bond. So it is an unsaturated fatty acid. Unsaturated fatty acid. And linoleic acid. l- Linoleic acid, it has got two double bonds. So it is also an unsaturated fatty acid. And linolenic acid, linolenic acid, it has got 3 double bonds. So it is also an unsaturated fatty acid. And only palmitic acid, it has got no double bonds. Palmitic acid, it has got no double bonds. So hence it is a saturated fatty acid. Saturated fatty acid. So option 4 is the correct answer. Then it is told nanopeptide contains. So a nanopeptide, it means that three, so 9 peptides are there. So the rule is that if we have, so a dipeptide, a dipeptide has one peptide link linkages. It has got one peptide linkage. Since why, if we have two peptides, then it should have one peptide linkage only, and a tripeptide will have two peptide linkages. A tripeptide has two peptide linkages. Since why, if we have three peptides, then it will have two peptide linkages. And so a nanopeptide, it means that it has got 9 peptide. It should have 8 peptide linkages. 8 peptide linkages. So how is a peptide linkage formed? A peptide linkage is formed from two amino acids through the elimination of one H2O molecule. So our peptide linkage is formed. A peptide linkage is formed how? Formed by two amino acids. Formed by two amino acids by elimination of one H2O molecule. So it means that if we have like 4 amino acids or 4 peptides, then it means that it should have 3 peptide linkages. So it means that a nano peptide should have 8 peptide linkages. So option 2 is the correct answer. And here it is told an example of a sulfur containing amino acid is. So an example of a sulfur containing amino acid is cysteine. Since the structure of cysteine is like this, cysteine structure is COH, H, NH2, this CH2, SH. So it has got sulfur. Sulfur is there. So option 3 is the correct answer. And for lysine, the structure is like this, which is CH2, CH2, then CH2, another CH2, and then here NH2. Here we have H, here we have NH2. Here we have COH. So this is called lysine. And the structure of serine, serine is CH2OH and CH, COH, and H2. So it is also an amino acid. Now, amino acid, it means that it should have an amine group and the carboxylic acid group, which should be attached to the same carbon. Then it is called as an amino acid. So all these four are amino acids: cysteine, lysine, serine, and tyrosine. The structure of tyrosine is like this. So this is called tyrosine. So only cysteine has got sulfur in it. So option 3 is the answer. Then it is told which of the following is not present in a nucleotide. So as you know that nucleotide contains uh, adenine, it contains adenine, then guanine, then thymine. So adenine, guanine, sorry, thymine, and cytosine, and uracil, and a pentose sugar, should contain a pentose sugar, and orthophosphoric acid, which is H3PO4, orthophosphoric acid. So it contains guanine, adenine, cytosine, and uracil. So it is not having tyrosine. Tyrosine is not present in nucleotide. So option 4 is the correct answer. Then it is told that glucose contains in addition to aldehyde group. Now the glucopyranose unit, which is glucose, obtained from glucose, it is like this. Okay, it is HOH, OH, H. This is OH, H, H, OH, and HCH2OH. So this one is the primary OH group, and the other ones are secondary OH groups. So it means that it has got 4 secondary OH groups and 1 primary OH groups. So the glucose will have, it has the aldehyde group along with one primary OH group, and four secondary OH groups. So option 2 is the correct answer. Then it is told that distinctive and characteristic functional group of fats is. So it is an ester group. It should be an ester group. Since why? Fats are actually higher order esters. Fats are actually higher order esters, which are by combining formed by combining the higher carboxylic acids, combining higher carboxylic acids, which are RCOH, and higher alcohols, which are ROH. Okay. So from carboxylic acid and alcohols, we can obtain the RCOO R dash, which is the esters, which are the fats. So it is the characteristic functional group for fat. So option 2 is the correct answer. Then here it is said that at pH equal to 4, glycine exists as. So now glycine as we know that it is an amino acid. Glycine, it is an amino acid whose structure is somewhat like this. H2H, uh, sorry, H2. Good. So it is CH2NH2COH. So it is an optically inactive amino acid. So it is CH2COH NH2. So at pH equal to 4, pH equal to 4, it means that it is an acidic solution. Since why? If pH is less than 7, it means that it is an acidic solution only. And if pH is equal to 7, then it is a neutral solution. And if pH is greater than 7, then it is an alkaline or basic solution. So pH is less than 7 here, pH is equal to 4, so it is obviously an acidic solution. So it means that the solution has got more amount of H plus ions, H plus ions. So now when H plus ions will combine with CH2, COH and NH2. So now as you know that glycine is an amphoteric acid. Glycine is an amphoteric acid. Since why this COH group, it can give one H plus ion, which can act as an, so glycine can act as an acid also, and the NH2 have one lone pair which it can give, so it is acting as a Lewis base also. So it is acting as a Lewis base, or it is acting as a Bronsted acid, since it can give one H plus. So it is either acting as a Bronsted acid or a Lewis base. So it means uh, H plus ions can attack on this NH2, then it can form NH3 plus ion and CH2 and COH. So in excess amount of H plus ions, it will form NH3 plus CH2 COH only. So hence option 1 is the, no, option 2 is the correct answer. Then here it is told insulin regulates the metabolism of. So insulin regulates the metabolism of glucose. Insulin regulates the metabolism of glucose. So option 3 is the answer. So the rule is that uh, promotes insulin promotes the metabolism metabolism sorry insulin promotes the metabolism and the storage of glucose also, the storage of glucose in liver and in muscles and in tissues adipose tissues. So option 3 is the answer. Then here it is told that test acrolein test is positive for. So acrolein test is positive for oils and fats. For oils and fats. So option 3 is the answer. So actually what happens? Oils and fats contain the molecule which is glycerol. So the glycerol which is present in fats, it reacts with the uh, potassium hydrogen sulfate KHSO4, which is a dehydrating agent. It means that it will remove one H H2O from the glycerol, and it will form an unsaturated aldehyde like CH2 CHO. So it forms an unsaturated aldehyde, and this CH2 CHO, which is uh, uh, which I can call it is uh, propionyl propionyl. So it is a it is also called as acrolein, and this acrolein is a bad smelling compound. It is a bad smelling compound. So hence the oils and fats will give this acrolein test. So option 3 is the answer. Then here it is told the amino acid which is not optically active is. So it is obviously glycine. So the structure of glycine is CH2 NH2 COH. So o- obviously here it is not having any chiral carbon. So there is no chiral carbon here. So it is not optically active. And all the other three are optically active only. Since why alanine, the structure of alanine is CCH3 COH then H NH2. So it is alanine. So here we have one chiral carbon here. And in case of serine also, as you know, the structure is CCH3 COH OH and H. So here also we have one chiral carbon. So it is optically active. So alanine is also optically active. And in case of lactic acid also, and yeah, and in case of lactic, sorry, this one is lactic acid. This one is the structure of lactic acid. So lactic acid is optically active, and serine structure is like this: CH2OH COH NH2 this H. So here also we have one chiral carbon. So serine is also optically active. So the only optically inactive amino acid is glycine. So option 1 is the correct answer. And here it is told the metal present in insulin is, so that is zinc. So zinc is present in insulin. So option 3 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter Biomolecules. So still any doubts if you have, then please write that in the comments section. We shall obviously clarify them. Also, please install our Sapience Education application where we shall upload some important previous year, some important questions which are based on the previous year PCT exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.